Hey guys, welcome back. It's Friday afternoon here. I think it's the 21st of July, and cleaned my shop, straighten it up a little bit, vacuum the floors, carpet in here. When I first originally wanted this, I wanted tile. No, not tile, but oh, what do you call that stuff? Vinyl flooring, like vinyl tile, like in our old TV shop. It was white and, if I remember right, it was white and black checkers, and I wanted that in there, but I decided to go with carpet because with this building built like it is, it's off the ground, so I decided carpet will give me another layer of insulation. So anywho, with all that being said, first off, a little update on this Dumont right here. I found the flyback, a replacement flyback. I'm waiting on word about a yoke for this thing, and if that comes through, hopefully I'll have a flyback and a yoke for this guy. Get them in, we can redo the chassis, get all that working, and we might just have a working TV right here. Wouldn't that be awesome? Second update is on this guy. Replaced all the capacitors in it, and I had to go in and do some work, and I started recording a bunch of stuff on this guy, but it just got so helter-skelter because I was trying to figure out how it worked and figure things out, and I was just going back and forth, and it wasn't a very coherent video, so I just scrapped the whole thing. Just suffice to say that after some adjustments and stuff like that, I've got this thing to where I think it should be, so I won't know until I get a receiver to a television to check it with. But anyway, I've got all the BNCs, all the microphone connectors here changed out to BNCs. Wasn't no big deal. All the filter caps have been changed. That cap there, this main filter here, was bad because after it ran a while, the thing got very hot. So here's 3 of the capacitors right here. Those have been changed, and the 3 inside this have been changed, and then just mounted them underneath. Had to do a little bit of alignment on here, but it works. It seems to work. Does what I want it to do. Anyway, I don't know where I'm going to put this thing yet. Don't have a clue. So I'm thinking about making some room in here, getting rid of some crap that I don't use, put it over in the storage building, and making me some room here. Because like the grid dip meter here, there's a no transistor tester here. I've never used it. That's my other CRT tester. That can't go. My substitution boxes right here, my resistor capacitor stuff right here. Motorola test set. I'm probably going to take the batteries out of it and put it in storage. This was my little SDR right here. I'll probably find another place for it. And I got 2 more transistor testers here that I don't use. I may put that in storage. This here I'll probably put in my house to get rid of. And I can clean up about 2/3 of this rack here. That will give me a place to put this test equipment that I don't use a whole lot. Because if I don't use it a whole lot, I don't think it makes any sense to put it up here. So it's just when I need to use this, I can take it down off the shelf, put it here. So anyway, where was I? Oh, speaking of CRT testers, the other day I was checking the CRT in this guy, with this guy right here, this model 466, and the thing was acting really strange. The filament voltage wasn't working properly, so I'm decided it's going to be my little mini project, and see if we can figure out what's going on with it. But just opened it up just a few minutes ago before I pick up the camera, and it looks like a main filter cap here. We got 2 caps here. The Illinois brand. It has been worked on, I will say that. So before I do a whole lot here, switches are going to need clean. They're pretty corroded, or oxidized, should I say. So these will need to be cleaned. But I'm going to find the manual for this, read up on it a little bit, and get familiar with it. And like, look how bad that's corroded. I mean, oxidized right there. So we're going to clean all this stuff up, figure out how it works. I bet you we got some resistors out of tolerance on this bad boy. Let me get all that information that I want to, so I won't be like shooting in the dark here. And I think we can make a working tester out of this. I don't think it's a big deal, but I want to find out where the filament gets its voltage from, look at the power supply caps and the power supply itself, do something about these funky little knobs here. That's an old TV knob if I ever saw it. Anyway, that's the next thing I got going on, and that sound of that phone there means my wife and grandbaby's home. So, and he's not feeling too well, so I'm going to go in there and take care of him. So I'll be back when I can and resume this. See you then. Okay, on this little 466 here, here is the heater adjustment, or the heater power supply right here. Let me get you on frame. Comes off the main power transformer, and it's just real simple here. It's multiple taps on the secondary of the heater filaments section of this power supply. Make sure I got y'all wide. Okay. Anyway, this, what we're interested in is this black wire coming off the center connector of the rotating gang switch right here, and then the gray wire, which is coming off the center of the wiper. So we're looking at those two right there. I want to see what voltage that we have coming off there. So have a feeling this heater adjust is open. So let's go get this hooked up to the voltmeter. And what we're looking for here is the filament voltage select switch right here. Here's the gray wire. I'm sorry, this is the black wire right here. Goes off to the center tap right here. That goes up here and feeds the cable right here. And then here's the gray wire right here. Comes over here and it winds up going over here too. So basically all I'm interested in is what's going on between here and here. So let me put y'all in a tripod and get this next shot set up, and I'll be back. Alright, got y'all in the frame. I think y'all got a decent shot here. Let me bring that down just a little bit. The voltmeter is set for the AC mode. It's applied to the center tap right here of the center pin of the filament voltage switch, and also the gray wire, which is the center of the filament adjust control. So I'm going to apply power, and I may have to pick this up because I think it might be in the off position. But let's see what we got coming out of this bad boy. There's it. The filament is turned on. I have 8.96 volts registering right there, and the heater voltage on the meter is only registered 4 volts. I'm going from 2.8 volts to about 4 volts. So let's see what it does on 12 to 14. No, it doesn't even go all the way up. So there's other problem. The voltmeter section must be bad, because this is telling me everything is working fine, but the voltmeter on the front of the device is not working. So wasn't expecting that. So let me look at the schematic again, see what its measurement points are, and see if we can figure that out. This shouldn't be too big of a deal. Alright, so look on the schematic right here, the filament voltage that's being measured. Make sure I got this right. There we go. The filament voltage being measured is coming into this test point, or this connection right here, and this test point right here. Kind of weird what they're doing here. Maybe I got that wrong, but anyway, I'm interested in this section right here. There's a 500K heater calibrate control right there. There's D5 and also R2. So those 3 items plus this C2, which is a 0.22, which is right there. So I'm pretty sure that's okay. D5 is this is the diode right here. In dollars to donuts, the 100K right here. It's going to be R2. R2! Anyway, and this must be the control right here that I'm looking for. R1. That's probably it right there. This is R4. Let me see if I can turn this off so I don't get bit. Yeah, this is R1 right here. This is the one we're after. So let me get reset up in this. I'm going to support this in my little vise so I can stand it up. We'll reorient the camera and let's play with that to R1 because I have a feeling that might just be the problem. So I'll bring you back. Alright. I'm on a mini tripod, believe it or not, on this big old Sony camera that I have. So anyway, the voltmeter that we want to measure is the same test point we were measuring a while ago. So I can get it to stand up. I still have it on the same test point as I just said, but what I want to do is, first off, I see the meter itself is not zeroed. I have the power off to the device. So what I'm going to do real quick is I'm going to short those meter connections to the meter itself. I'm going to short the meter connections, and then I'm going to get an adjustment tool and find one. See if we can zero this meter. And not zeroing. That's not good. Oh my Lord, I hope I don't have another meter movement bad. I don't know. Let's go ahead and proceed. I'm going to apply power. Turn on the adjust filament. And we're going to put this on the 5. Yeah, I'm going to put this on the 5 to 8 volts down here. And I'm going to adjust this meter for 6.3 volts. I'm going to probably make it 6.3 something. I don't know. Let's just adjust it for like 6.35. Because you know once we apply this to hook this up to an actual circuit that it's going to drop a little bit. Anyway, right now the meter is reading around 3.5 volts. So now let me get a little adjustment. Let me just get a small screwdriver. Should have had that already, right? So let's just play with that control. It's I have a feeling that control's not good. Yeah. .3 right there. Somebody been dicking around with this thing. Got it on the 8 to 10 volt now. That should be 8 point what? Well, that says 8.4. That should be 10. There's 10 there, showing 11. Oh my Lord. This is not good, guys. Now this could be because it's unloaded, but I don't think so. I got it on the 12 to 14 volts. So right there is on the 12 volts, showing 16 volts. Oh my Lord. Is it because it's unloaded? I think that's probably what it is. It's not right because it's not loaded. Certainly isn't tracking very well, is it? That's 6.3 right there. I don't know. God, I hate these things sometimes. They don't want to act right. They don't behave logically. I tell you what, let's kill the power to this thing, and I'm going to check some resistances. I want to check. I don't trust that diode either. Can y'all see? Yeah, there you go. I want to check this R2 right here, this 100K, and I want to also possibly check D5. Could be damaged, who knows? I'm not sure about that poly cap. It's probably okay, but I want to I think I want to check R2. So let's check R2. So let's go ahead and put this on ohms and see what R2 has to say. Probably looking for C3PO, who knows? 20% resistor. Take your bets now. Where is it going to be? We don't know because my clip lead won't stay on. Woohoo! Alright, here we go. Well, to my surprise, it's showing 109.7. Well, I was surprised. Yeah, that surprised me a whole lot right there. Well, what do you think about that, Ma? Let me pause you a minute. I'm going to put this under a load. I'm going to I have a little bulb here that I use for, again, I can't see the display. Alright, this little bulb right here, it's got a 2 amp load on it and a 1/2 amp load. It's 12 volts, of course. So I'm just going to put this in right here with the meter circuit where we were measuring just a few minutes ago. But you can put a load on this thing because you don't adjust these unless the CRT is hooked up already. So I'm putting my voltmeter on there. Let's put this voltmeter on AC, I believe. If it don't snap off, which is usually what the case is. Alright, everything's in frame. Not quite. Just point you down. There it goes slightly. There. Alright, I'm going to start at the minimum. And let's do this again. I have a feeling this meter movement's damaged. It probably has a weight missing off of it. They have a counterbalance inside there and they're very delicate. And because this thing doesn't zero, and if you're missing the weight off the meter movement, it will not track properly no matter what you do. Anyway, here we go. We're going to set this up for 5 to 8 volts. We're going to set the dial for 6.3 and they're measuring 6.23. So let's reset this for 6.3. We're going for exact numbers right now. Let's turn this up a little bit to where it measures 6.3 because I'm doing it backwards. There we go, 6.3 right there. Now let's turn this down till it says, there's 6.3. Now, hopefully this load will make this thing track better. So let's run this up to about 8 to 10 volts. Let's run this up to about 9 volts. 10.12. Now granted, the different voltage on this bulb will make depending on how much voltage you have, at 12 volts this thing has a certain bulb resistance. As you go down in voltage, it's not as hot, the resistance doesn't go as high, which means it's a lower resistance, which produces an unequal load to this thing. What I probably need to do is find me an 8 ohm resistor, a couple of 8 ohm resistors, put about a 4 ohm load maybe on there, and let's see if that works, because this could be messing with my It's set to 8 to 10 volts. I'm setting at 10.10. Let's go up a little bit. Let's go up to 12 volts exactly if it'll set. We're just kind of figuring out, you know, feeling this thing out. That's 12.01, and it's at 12.01, and it's telling me it's just a little bit, about 10.2 volts. Meter is not tracking. See, that's about 14 and a half. That's showing 15 volts right there on the meter. And we're down here at about 11.7, 11.8. That should be full scale. Well, crap. See, it won't even do full scale. So, I think what I'm going to do is I'm going to replace that resistor with one more closer in tolerance. I'm going to replace that diode, and we'll do this again. Maybe it's a diode is a little bit weak. You know, one time I never heard of a weak diode. They say, oh, semiconductors don't go weak. But after you're this old, this thing was made in the 70s. And as you well may or may not know, a lot of electronics now that was built that long ago, there are transistors that are weak, and there are diodes that are weak, because the semiconductor junctions inside break down, and they're not complete and whole as they were 30, 40 years ago. So they do get weak. Anyway, enough of that. Let me get my soldering iron out and see if we can pull some of these components, and I'll bring you back after I do an analysis. Okay, I checked the diode with my triplet VOM right here, this guy, and I checked it on the 100K scale. I hadn't replaced it, but the 100K was about 10K high, so I just went ahead and replaced the 100K with a new resistor. So let's see if it's made any difference. I don't think it has, personally. Now I'm at 16.5 volts here. This thing should be all the way pegged. And the variable control, the variable resistor is all the way up, maxed out. So I'm wondering, there's something else in here going on. Yeah, I'm wondering if there's another part of that circuit I'm not seeing. Could be something downstream to it. So let's just have... Alright, it's been a little while since the last segment. I was right about the meter movement. The meter movement was messed up. It looked like it had been dropped. The taut spring on the back of the meter movement was just, it looked like it's been in a car wreck. Looks like Ant-Man in his little quantum size got in there and had a battle with the latest bad guy, whoever it is. But you'll love this. Hang on a second. Heath kit to the rescue. I took the meter out of this here Heath kit, model IT121. Same exact footprint, everything. I had no idea. This is the old one right here. Had no idea what its specifications was as far as microamps or milliamps or whatever. Here's the escutcheon off the Heath kit. But it fit in there perfect. I didn't have to do anything. I had to do one thing. The spacing on the holes right here for the meter, right here and here, were different on the new panel. They were a little bit wider out, and a little bit lower. I had to cut just a little bit off the bottom of the meter plate so it would fit inside there. Kind of a redneck thing, you know, but look at this. 6.3 volts. If you can move this stupid thing out, look at there, it's almost exact. 6.3 volts. Now, let's go up to 10 volts. Watch it make a liar out of me. Around 10 volts. Look. 9.92. 10. This says it can be up to 20% accurate. 12.6. 12.47. Bring it up to 13.8. 13.62. How about that? Here's the old meter. KEW Electric, made in Japan, 7203. So I believe that's the original meter for this, so I'm not no doubt of that. Now here is the schematic, the parts list for this. Resistors and controls are 1, 3, 4, 7, 8, 14, 9, 12, 13, 16, 17, blah blah blah. All resistors, few handful of capacitors, which I have not tested, but the 0.22 at 200 volt measured good, by the way, on my Syncor right here. The transformers and switches, ain't nothing wrong with them. The 3 diodes, as far as I know. The function switch and all that's fine. The adapter assemblies, case. Oh, there's I did not see that. ME1 right there, meter. I wonder if I can order one of those. Wouldn't that be something if they still had one of those in stock? Anyway, let's see. Yeah, there was an adjustment on here. Compression adjust right here. The meter does connect to this compression adjust. It does interface with it. And I'm wondering if that is like, keeps the, when I played with it, it did affect the meter movement. It acts like when it gets up to full scale, it starts conducting to protect the meter. That's what I'm thinking. It's like a variable shunt. That's what I'm thinking, the way I'm looking at this circuit. And I thought maybe that had something to do with it, but I played with it and played with it and played with it off and on, and I even checked these 2 diodes. They seem to be alright. And if you look right here, you see how one way that this thing will conduct and bypass this circuit right here, then when it's all AC, by the way. This whole thing runs off of AC, but when the polarity switches, then it goes through the compression adjust right here. And that's this little sucker right there. And let me get my light over here because I want to show you something. Alright, you can see it. See that little black line right there? This is the compression adjust. That's where I marked it when I originally started working on this. And look how after I got through messing around with it, that mark is just slightly off. I'm going to move it back over here, right there where it's back. This is where I found it. Before I touched it, I marked it. Well, let's have a look. 13.8 still, 13.66. Oh, and by the way, I do have it. It is accurate when you put a load on it. I see somebody. It's the interloper. Let's adjust this for 13.8. All right. Let's see if I can short something out here. Let's go back to 13.8. I got a visitor. This pet they let out of the zoo comes sees me every now and then. There we go. So hey.
Hi.
That's one of my granddaughters right there. They let her out of the zoo to come visit. Say hi, folks.
Hi.
A couple of minutes. Give me a couple of minutes and I'll be done.
Okay.
Almost through. Alright. Let's check. Alright, let's see. We'll set it back down to 6.3. Look at there. This thing, that is accurate. That is good. Now I'm not afraid to plug this into a CRT now. That is good. I can't believe that actually worked. And you can see if you look down here how I've done that. I had to just kind of wedge it in there because it was just narrow, but it should work because this cover will hold it in place. I just can't believe it. So I guess tomorrow I got a thing. I got to go down to hunting camp in the morning. But in the morning when I get back, I will take these capacitors here and check them, and if they need to be replaced, I'll replace them. And then I'm going to kind of leave it alone because everything is like it was. I did not adjust this red control right here. I did adjust this one and this one, but that's the filament voltage adjust or meter adjust, and this is the what did they call that? The compression adjust. It's back where it came from, so that's fine. So if this thing was accurate, nobody else diddled with it, this should be good to go. But I will check this. I'm sorry, this capacitor and these two here. There's only 4 of them. 1, 2, 3, 4 in the whole thing. So I'll check that in the morning when I get back from my little excursion and see if they're good or bad, and we should be able to wrap this bad boy up. So I'll see y'all in the morning. Alright, next day. I actually found some literature on this thing, how to operate it, and also a field calibration. So let's take a look. Let's jump into this. We already have done the heater voltage calibration yesterday. So today, emission calibration. Equipment needed: a milliamp meter and a 100K resistor. Well, I had to borrow this out of my work truck. I got a Fluke 87 version 3 or Mark 3. I've got it set on milliamp amp right here. I'm going to start off with milliamp microamp to common. The only meter I have that works. This one seems to have, I've never fixed that problem in here, and also that guy there, I need to get some fuses. Apparently they've been out forever. Anyway, and a 100K resistor. So I need a, so let's see. Put that over there where we can see. Turn the light on. Anyway, through all the BS I was just talking about, what we want to do is turn the 466 large function switch, this guy right here, to read emission. Alright, turn the color gun switch to the red, black, and white position. That's up here. And then it's in red, black, and white. Turn the G2 pots, red, green, and blue, to fully counterclockwise positions. So that's clockwise, counterclockwise. In other words, they're all the way down. Alright, so set the milliamp meter to a range capable of reading 300 microamps. Connect, we got all this. Connect the negative lead to pin 11 of socket number 1. Connect the positive lead to one end of the 100K resistor. Connect the other end of the resistor to pin 10 of socket 1. So in this case, I just connected right here where those leads go in to the switch. You know, same thing. Alright, let's turn it on and slowly turn the red G2 pot until the milliamp meter reads 300 microamps. Then we have to adjust R9. We adjust R9 to the emission cal trim pot until the 466 reads 50 on scale. So let's make some smoke. So alright, so let's see. Alright, slowly turn the red G2 pot until the milliamp meter reads 300 microamps. Let's see if this even works. Well, that's 0.3 milliamps. Let's try this again. Slowly bring it up. You know, I have not checked the power supply on this thing. Maybe I should have done that before we done this calibration. So right now we're at 50 milliamps. And like I said before, when I was working on that WaveTech, sometimes when you have problems with something, you want to know if it's working right or not. Just run a calibration on it. See, I'm not sure what's up with that. See how that thing's just flaky all over the place? Going from, you see what it's doing. I mean, we're at 4 milliamps right now. I mean, it goes from one extreme to the other. Just wondering if the pod's bad. I mean, you get up to a certain spot and all of a sudden it's on. Okay, something else is up. Alright, so let me pause this and I'm going to go in and check the pot, and I'm going to go ahead and check the capacitors, which is what I should have done before I even started this venture. So that's what I got to do next, so I'll see you in a bit. Alright, moving right along. I checked all the filter capacitors, the three that's in here. This guy right here, which is a 50 right here at 450 volts. These two are 5 microfarads at 450 volts. They all check okay. I mean, the Syncor didn't really like them, but it's a little persnickety, and it's really good. In my opinion, this thing is really good on anything other than electrolytics. Electrolytics, it's kind of like, yeah, well, it's good, but it ain't good. Yeah, I don't know. I like this guy for electrolytics. I like to watch that eye. It tells me more of a in-circuit response. In other words, I put 450 volts in a 450 volt capacitor, and if that eye opens all the way up, I'm good with that capacitor. This guy here, it wants to charge up, and the book tells you its initial reading is telling you, yes, it was leaky. The capacitors are a little bit leaky, but they're not going to stop this thing from working, so I'm not going to worry about changing them until I have to. But anyway, the way this alignment was setting for the emission, you remember how this the red and black and white control, it was just like if you turned it, all of a sudden you didn't get much of a response, and all of a sudden it's like boom. Well, that's indicative of a bad control. And if I can make all this mess work without all these stupid test leads jumping off, which they've been there for 10 dang minutes, and all of a sudden now they want to decide to come off. But if you look, red test lead and the black is across the control. The control is a 100K control, and I've got 10 volts applied to it right here on my bench, one of my bench voltmeters. I just have 10 volts across it. They ain't gonna hurt the control at all. The meter is out of the, I pulled the meter out, the meter board off, so I could, but anyway, I'm gonna take my voltmeter right here, okay? And I've got the negative right here attached to the negative part of the power supply. So, which is attached to one side of the pot. So there's my reference. So I'm just going to take this right here and go to the center. If I can get in here. Alright. Attach the center. So now I've got 10 volts across the control. And all I simply have to do is turn it. So I'm going to turn this thing from minimum. Here we go. I'm turning. I'm at about 12 o'clock position. You notice it has not changed. I'm going to about 1 o'clock, 2 o'clock position, 3 o'clock position. All of a sudden I get about 4 o'clock. Look at there. All of a sudden it starts boom. See that? That pot is bad. Let's go over to the next one right here in line, and it is wired in parallel. Each side of the resistance is wired in parallel on each one of them, and I'll show you right here. This is the red, black, and white, the green, and the blue, and you see they're all wired in parallel. So 10 volts is across each one of those. Okay. So all I simply did was move my test lead over to the second pot. Now we're going to do the same thing. We're going to start at minimum. And this 10, I'm bringing it up. As you can see, I'm already at, excuse me, 7 o'clock, 8 o'clock, 9 o'clock, getting up close as we're going across the trail. You see how that one does? That control is fine. Alright, let's do the same thing on the next one. Alright, I just got to get to it. Bear with me. We'll do the same thing. I'm going to turn it from maximum counterclockwise to clockwise position. Oh, this one's bad too. Surprise, surprise. Yeah, sir. So, I was not expecting that. So far, our meter movement was screwed up. Two variable resistors are screwed up. Haven't even checked the other one yet. May as well do that too. So I don't know if they're just dirty or bad, which means I've got to unsolder them, pull them out, take them apart, and go from there. But I'm hoping this dude right here might have, I don't know, I may or may not have some. These controls are linear, they're not logarithmic pots, which means I can't go find an audio pot and put in there. But I think I might have some 100Ks. I think. But anyway, let me check this one right here, see how it acts, and then I'll pull one of these out somehow or another, see how, do an evaluate it, see what it's going to take. If it's fixable, fine. If it ain't, we'll see if we can find a replacement. That's where I'm at. Bring you back. Alright, bringing out the big guns right now. Get my trusty old, I love this thing, the Heiko FR301 right here. And get it warmed up here. And I'm just going to suck the solder out of these, try to get these leads out cleanly, because these wires right here on these things, get out of the way. These leads on here right there, they're just kind of, you ain't careful, you overheat them too much. So I'm going to try to get that out with no casualties. It'll clean, get out that way. When I put this back in, it'll look good. Oh, look. I just noticed something. Alright. Oh, this ain't going to be good. Look right there. If you can see it. This control has been removed before. See how I'm... That ain't good. Boy, this thing... I was supposed to have been through this thing yesterday. Hell, I didn't know it was going to turn into a 3-year event. Another one of them Gilligan's Island tours type things. Just, 3-hour tour. This is taking 3 years. But we're going to get it. And by the way, I'm holding this, still doing this gorilla style as far as the camera. However, I have a little small tripod that actually came with one of my GoPros, but it's you can collapse the lead on it. It's only about 6-8 inches tall, but you can collapse the lead on it, and it makes a great handle, and it sure is a lot more stable this way than using the handhold, which is what I've been using on this camera. So hopefully this ain't too shaky cam for you guys anymore. I know some people get upset about it. I carry on about it all the time. Anyway, that thing's ready to go. I'm going to put you down. It's no point in me watching me desolder that. You've seen me do that 100 times. Just look at some other videos where I've taken this junk apart. Anyway, let me get that out and let's check it. I don't have high hopes. Okay, finally got the control out. There she blows. Looks like a central lab. Yeah, it is a central lab. And you can see the ears on it right there, the mounting, the tabs on it. Let me get, yeah, this thing's been in there before, and it looks like he just pulled it out and didn't unsolder the wires. But it's a Central Lab. That look like a part number on it. What's that? 008-125-9-001. I wonder if this thing is open. Let's measure it. Yeah, it's still shaky, Cam. I realize that. But let's see if it's open. I'll put y'all guys in a tripod shortly. Yes, it is open. It is open. Well, there you go. So let me set this up on a tripod, and matter of fact, I'm just going to open the resistor up instead of using a tripod. I ain't going to bore y'all with all that. I'll just report on what I found. Well, I lied. I have you on the mini tripod, and I just got you on top of the 415 here. So anyway, I'm just taking my, right here on these little tabs right here, I'm just taking my little stiff pair of cutting pliers. Don't use your expensive precision ones right here. That's for cutting leads. That ain't made for mechanical. Anyway, just taking the pliers and twisting the tabs like this. I mean, it's kind of, I almost didn't record this because it's kind of like a duh. Anyway, pull it apart. Oh my goodness. Yep, it's got that lovely smell. Let's see here. See it? No fixing that. You can spray all the contact cleaner you want to. No fixing that. So, let's go see if I got 100K. I love this little mount on this camera. So, I have a whole buttload. Oh, look what I found the other day at a flea market. My wife brought me. I've got a whole case of 8-tracks. That's just a few of them that I didn't have room for. And the 8-track player that we worked on the other day, that guy right there, works fine. I didn't record it. I just figured I'd put it in an update. But that thing works great. Oh, here's the rest of the 8-tracks right here. Thing works good. Some of them tapes are missing the, the foam inside. But works fine. I didn't feel like it was worth making another video. I just thought I'd mention it. So let's find all my controls. Where's all my controls? I have tons of them. Miscellaneous pots. There's one right there. And I'm looking at one there that could be perfect. I'm thinking that's 100K. Well, wouldn't that be awesome? Well, it's a 50K, dadgummit. Two and a half meg, that ain't it. Come on now. 10K, I got a bunch. I got a crap load of 10Ks. Well, this sucks. 10K. Alright, I won't subject y'all to much of that. I know I just went off the target, no telling what y'all were looking at. And this might even make it in the video. So let me see if I can dig up some parts. I'll bring you back. Alright. I want to show you something real quick. There was a video early on in my video and YouTube career, you want to call it that. I worked on an old Dumont oscilloscope. Well, I got, every time I'd fix something on it, or it was always just, never really worked right. It was just worn out. Anyway, I gutted it. And all these pieces and parts left over. Well, out of all these pieces and parts, look what I found. Two 100K controls, almost identical to the ones, to the same specs that I pulled, the bad ones that I pulled out of there, other than these work, those don't. So this is kind of ironic in a way, but I'm thankful to the good Lord that I had these, and I gutted it from the old Dumont's oscilloscope. I've been using pieces and parts off that thing for years. But anyway, these two controls will go in here, hopefully fix this thing completely, so I can work on or recheck this Dumont set. There's some kind of irony in here. I ain't sure what it is, but anyway, I got to put that back in, come over here and do this other one, and we'll retest it again, and hopefully that thing will work. So I'll bring you back when I get all this crap done. Alright, got the second offender out, and it's the same way. It's been doctored on a little bit too, so let's open it up. Alright, same old trick. Yeah, I've used pieces and parts, and especially the nuts, bolts, and screws and everything out of that old Dumont scope. It has really given its life. Yeah, that's got to burn right there. Right there, it's gone. There's no fixing that. No fixing it. So anyway, that's that. Let me see what this text message is about. We'll put the other control in and put it all back together, make it clean, and we'll try again. Alright, I have got it put back together. There's the first one that was bad, that guy right there. This one seems to be good. This is the second one that was bad. So got all those changed, cleaned up, got the meter board back in. I think everything is kind of copacetic. So move this back where it came from without breaking it. So let me show you what I had to do. And you know, sometimes call me lazy, whatever you want to call me, but these three controls here had these knobs on it, and if you look at the back of the knob, it had the 1/4 inch you know, half shafts. However, the controls that I had were full shaft, they wasn't half shaft, so I had a choice: either cut the shaft and make a half shaft out of them, or just change the knobs to chicken head. And I need to readjust these two to match that one there. I just put chicken heads on there. It worked just fine. It still looks cool, other than the lines on there, but all these came off that old Dumont oscilloscope, but it does the job. Looks better than it did. So let's get everything hooked back up and get the test set back up, and let's see what goes on here. So let me get set up, bring you back. Alright, got you back on the mini tripod and got you in a favorable spot. Let's do this again. We're doing the emission calibration. We have the milliamp meter right here. The little fluke. Let's see, so we want to turn the large function switch to read emission. It's a big function switch you can't see back there, but it's read emission. Alright, so turn color gun switch to red, black, and white, which it is. And I need to calibrate this meter. Okay. Alright, so things like these are laboratory grade stuff, you know. Alright, so turn the G-pots all fully counterclockwise, so they all are. Set the milliamp meter to a range of reading 300 microamperes. Connect negative lead to 11 and positive lead through the resistor 100,000 ohm. Connect the other end to pin 10 of socket 1. Alright, so we got all that, or at least I think I do, hope I do. Applying AC voltage. Power is on, so let's try this again. You know what? This would work a lot better if I did that. Here we go. Now we got some stuff going on. Change that to, oh yeah, now I got 302. Since we changed this meter out, I'm kind of curious how this is going to work out. It's 301.5. So what are we showing here? What should we do? Adjust R9, the emission cal trim pot, to the 466 reads 50 on the scale. So 50 on what scale? Scale 5. So scale 5 is right here and it's showing 42. So we need to turn that up to 50. So let's find R9. It's a red pot up here on top. So red pot on top. There's a joke in there somewhere. See if it'll work. Old screwdriver's worn out. See if this will work. That's right on 50. We had more or less 300 milliamps. It's on 50. So we have the, so far the heater calibration is done. The emission calibration is done. Now the compression. So next thing we need is a milliamp meter and a 100K resistor, which we have. We've got to go back to read emission, which we are. Turn the color gun switch to red, black, and white. We're there. Turn the G2 pots fully counterclockwise. Boom, boom, boom. Set the milliamp meter to a range capable of reading 3 milliamps. We're going to turn this off a minute. So we got to stay in the same spot. Okay, we're pretty much doing the same thing. So we've got to turn the G2 pot until the milliamp meter reads 3 milliamps. Okay, so let's just turn it back on. Alright, so microamps, so we got to adjust this for 3 milliamps. According to the flute, that is 3 milliamps right there. Alright, what next? R4 compression, adjust trim pot until the 466 reads 100 on scale 5. It's almost there. Remember, that's the one I showed you yesterday that had the mark on it. Oh, let's see. We see. Turn it back down. Turn it back down. Right there. That is done. We have finished calibration of this device. Everything seems to work. So, yoo-hoo! That's the meter. Yeah, it's bleeding down. That's fine. Alright, so let me clean all this mess up. Put everything up out of the way. We'll put the meter back in its case, make it look good. We'll clean it off and then we'll test a CRT with it. So I'll bring you back. Alright, I have you back in the tripod. I've got the 466 back in its case. So we're going to test this Dumont again, the 17KP4. And it says to use socket 1, which should be this guy. So let's get this over here where I reach. Falling, causing major catastrophe. Alright, here we go. Set it power on. We just start here and it says adjust the heater. Adjust it for 6.3 volts. Right there. We have a filament lighting up in there. So now we check for heater to cathode leakage. There is none. G1 leakage. There is none. Set G1 voltage. Right here. G1 voltage is in the range. Alright, set cutoff voltage G2. That's going to be number 6. So I got to find number 6. Alright. And read emission, number 7. Right now it's showing in the bad zone. See, I didn't have a good tester before, so this thing may have been a bad candidate for restoration. Let's go back by the book. By the book, rotate knob marked 1. Select heater voltage. Proper range. Proper range is 6.3 volts. Rotate large central function knob to position mark 2. Adjust heater. Okay, we've done that. Connect CRT. Adjust heater voltage is indicated on scale 2, which scale 2 is showing 6.3. Rotate large function knob to 3. HK leakage. And unless I'm doing something wrong, it's showing a lot of heater to cathode leakage. Holy moly. Wow. That wasn't there before. So we have heater to cathode leakage. Wow. That ain't good. So rotate the large to G1 leakage. Okay. Alright, observe meter reading on scale 4. Scale 4 says it's okay. Alright. Let's go back to heater to cathode leakage. Yes. I can tap on it. I can tap on it and cause it to go away. I don't know if y'all saw that or not. I'll move y'all over here, which is a little bit better spot. You can see what the heck I'm doing. Tell me what I'm doing wrong. Zoom in. So look at there. Heater to cathode leakage right there. The heat meter. Filament set. HK leakage is pegged. And tap on the neck of the CRT and it goes away. This G1 leakage. G1 voltage. Let's go to that set large function knob to G1 voltage. So position 5. Alright. So now we want to use meter scale 5 to green line approximately 145 volts. So that would be 6. 1, 2, 3, 4, 6. What's it say here? Set large function knob, 5, and using knob 5, adjust G1 voltage on meter scale 5 to green line approximately 45 volts. Oh, okay. I'm doing that wrong too, wasn't I? Green line, okay, I was doing it wrong. It's the line on this scale right here to the green line. Boy, I was doing that wrong. Good. That's what instructions are for. Alright, so set large function knob to position 6. Set cutoff voltage. Alright, let's see. So we want to take and set large function knob to position 6, which it is. And color gun switch position mark red, black and white, adjust black and white red. G2 voltage control knob until meter pointer reading on meter scale 6 increases by 2 small divisions. So looking at 6, raise it. Does not increase. Alright, so let's just turn it about midway and let's read emission. Emission says good. Even though I can't get G1 out of it. Let's bring it back down here. G1 voltage is still on the green. Cut off. I think some of these say if you can't get cut off, well, that doesn't mean nothing. Go back to emission. So the emission actually says it's okay. I can't believe that. That says it's okay. I'm going to tap the neck again. Go back to G1 leakage, or heater to cathode leakage. Says it's a good too. Let's drop the filament voltage. You see the emission going down? I've dropped it down about 4.7 volts. We're going to bring it back up to 6.3. Check the heater to cathode leakage again. And it seems to be gone. Emission's good. Look at there, y'all. That's good news. I just had the G1 voltage, the G2 voltage. I didn't have it. The G1 voltage, I didn't have it set right. So I had it set like way down here. It's supposed to be up here on 45. So this is a pretty easy device to use. You just follow the numbers and look at the scale, and that's how you do it. G2 voltage, I did get it to raise up just a little bit. But the emission says it's okay, and like I said, if I reduce the heater voltage, you see the emission go down. So that's good news in a couple of fronts there. Emission's actually going up a little bit. I'm going to let it run. Alright, switch y'all back to handheld. And let's play here. Get y'all out of wides. Put y'all back in wide. Anyway, let's go down to HD. The heater to cathode short seems to have disappeared. Good. I mean, this thing has been dormant for Lord knows how many decades. But it's actually went up, the emission. So good. I say the restoration of this CRT tester was a success. Battery's about to go dead on this camera here. It's got about 1 bar left on the battery, but boy, that was an adventure, wasn't it? So what did we wind up changing? We changed one resistor, 1 meter movement, which thank the good Lord above, I had another meter that was almost the same value. Wow. And we changed 2 of the G2 controls that were open, that were burnt open. You saw it yourself. So did a calibration on it, so I trust it. So that's that. Great video. It was great, and I kind of enjoyed working on this thing. It's cleaned up now. I'll put some proper screws in the cabinet, so it's good to go. Let's take one more quick look at it. Oh, and I haven't shown you. Here's my other cables that came with it. That right there is an extending cable, I believe. So I'm really good to go on what I work on. There's my chicken head, so that'll stay on there. I put a chicken head on that one. And one day I'll order the right controls for this. It works right now. There's no point in it. I'll save the knobs. I'll save the knobs and all this. I'll put it in a bag and just put it up. I'll probably just put the bag in here. That way I'll know where they're at. But it works. And it's good to know that this CRT is good. So anyway, that's that. I appreciate you guys watching, and I got a little handshake. I don't know what it is. My hands shake here a lot here lately. I don't know if it's over caffeination or other things. But hey, thanks for watching, guys. I appreciate each and every one of you guys, and I guess the next one will probably be working on the Syncor CR70 to find out what the heck is wrong with that thing. But it's a success. Thank y'all for riding along. We'll talk to you guys later. Bye-bye.